Hi guys, welcome to part 3, an explanation of visible thinking. Just before we start, I just want to clarify that this is not Visible Learning by Hattie, which you may have heard of. A lot of people get confused because of the word visible in both titles, but the one we're talking about today is Visible Thinking, which is part of Project Zero, as you've already heard about. So how often have you looked at a student's work and gone, how on earth did they come up with that answer? Well, with visible thinking, we get to see the inner workings of students' thought processes, which will help us as teachers unravel the apparent logic behind some of those more original answers, as well as helping students discover their thinking processes and how they came up with the answers that they did. You may have been using visible thinking without even realising it, because to paraphrase Shari Tishman and Patricia Palmer, technically, visible thinking is any sort of observable representation that reveals the learner's unfolding of ideas as they think through an issue, problem, or topic. So any activity that gradually reveals how students' thinking has changed or evolved over the course of that activity is technically visible thinking. What we're focusing on today is the ways that Project Zero gives us to incorporate visible thinking and visible thinking routines into our classroom. These 4 people here you've either already encountered or are about to encounter in this presentation, and are kind of the key players in visible thinking, but also a lot of other related projects, including being overall directors of Project Zero. So finally, what actually is visible thinking? It's a system of thinking routines designed to make student thought processes visible to both the student and the teacher. It is designed to foster a culture of questioning, observing, and analysing in the classroom, and it is designed to be used across all subject areas. It goes deeper than just teaching thinking skills, because without the motivation or inclination to use these skills, or in fact being sensitive or aware of the times we have to use them, then we've created a case where students have some great tools, but no idea how or when to use them. Aiming for this intersect between skills, inclination, and sensitivity is hugely important when teaching maths, because I'm sure you all remember at least one test where you've been going about your classwork with no real trouble, then you get to the test and go, I've learnt none of this. Then when your teacher gives it back to you, he points out all the places that you've actually already done this skill, you just didn't notice that you needed to use it. We see that a lot with maths word questions, as most students have the skill, but they come unstuck through failure to recognise that this is now the time to apply that skill. And this is really what visible thinking tries to do, is go beyond just having the skills, being able to recognise when you need to use them as well. The way that visible thinking does this is through visible thinking routines. Now in part 1 you would have seen 21 different thinking tools, but this is where we need to make an important distinction. The core idea is to start with just one of these tools, implement it into your classroom and use it again and again until it becomes a routine. This is important so it doesn't just become a mere strategy to be used a few times then forgotten about, or only when the teacher tells you to do it. Doing it this way risks just addressing the skills aspect of that Venn diagram, and that's not what visible thinking is about. By making thinking a routine, you're cultivating thinking dispositions rather than just base level skills. In other words, students get into the habit of observing, analysing, and questioning. Now the word habit should have you drawing connections between Costa's habits of mind that we heard about last week. If you look at the 16 habits of mind and compare it to what we're trying to achieve through visible thinking routines, you'll see a lot of overlap, and I'll leave it up to you guys to think about which ones best suit this project. One great aspect of visible thinking routines is that Project Zero doesn't require teachers to be particularly experienced with any of the routines, and in fact they actually encourage teachers to pick one that they like the sound of, implement it in their classroom, and just learn along with their students and see if it suits their classroom. From there, it becomes a lot easier to see which of the other routines may suit your classroom and start to implement them based on the kind of thinking you wish to encourage, whether that's questioning, explaining, making connections, challenging ideas, or seeing things from another perspective. Here's a neat graphic of the different types of thinking you can encourage in the classroom, with a few of the Project Zero strategies listed along the top and bottom there. We've actually done an activity with Louise in class that fits in really well with one of these broader topic headings. So just give yourself a second to think back to our previous tutorials and see if you can remember which activity this might have been. As a system, visible thinking is essentially designed around 21st century learning. If you recall the questions up in the top corner of the infographic from the history section, what Project Zero as a whole is trying to answer is: how can we prepare our youth well for the changing demands of living in a globally connected and disconnected world? And how to prepare our youth for what comes next. This ties in quite strongly with the Alice Springs Declaration. We are trying to develop confident, creative, lifelong learners. There is a huge emphasis on resilience, imagination, and adapting to change, which is worlds apart from the prevailing attitudes that were around when Project Zero started, and the reason it was actually created. This is probably more important now than ever before. Visible thinking itself is designed to help students communicate their thinking and go beyond just listing basic facts. It is also highly collaborative. Most of the thinking routines are designed to be used in pairs or groups at least some stage of the routine. Finally, as a process, it encourages deep thinking, questioning, and challenging. It's pretty clear how this links to critical and creative thinking. Obviously, all of these points link very strongly to the general capabilities across the curriculum with critical and creative thinking, plus personal and social competence. Here's an example of a thinking routine called Chalk Talk being used in a secondary maths classroom. Here, the teacher puts up a prompt, in this case, what do you know about the right triangle? And the whole class has to respond. Obviously, it's difficult to read, but I just wanted to draw your attention to a few of the student comments. Firstly, a lot of it is off task. There's a couple of drawings and scribbles on there, which is to be expected. What we can see here is a real variety of student input, all of which is valued in this activity. First off, a student here feels confident enough to write, "Don't know this one." This may look like they know nothing or that they're not taking part in the activity, but really this is super important. To get a student to even admit that they don't know something is the first step in getting them to find out more about it. Rather than just pretending they've got it and struggling through it until the test, they're actually already demonstrating an awareness of their own learning. Next we have, it has a 90-degree angle, which is something we might expect from the recall level of Bloom's taxonomy. Again, for some students this might be the stage that they're at, and this is being celebrated by their contribution to this activity. Finally, we have a really interesting chain that represents the type of thinking and interaction that this routine is designed to elicit. Someone here has written, if side length AC is the same as side length BC, then angle A and angle B will both be 45 degrees. This already shows some extended knowledge of the topic, but more importantly, underneath somebody has written, that is cool, I didn't know that. So students are already starting to learn from each other through this activity. Further to this, someone underneath has written, it's half a square, which would be true if we're talking about the triangle where AC equals BC. Someone underneath has recorrected that to say rectangle, so now this is showing that the students in this class feel confident enough to correct each other, and you've got peer assessment happening as well. So this kind of interaction and this kind of extension on just the basics, I don't know, or it has a 90-degree angle, is really the type of thinking that this activity or routine encourages. The important thing is that all these comments, aside from the drawing of the monkey, are equally valued, and all of them tell the teacher something about where the student is at with their learning, which is really valuable as both a diagnostic tool and formative assessment. And additionally, it allows the students to reflect on their own learning, both in a comparison with other students that isn't in the form of a ranking, and also just reflecting on their own knowledge and seeing that they do actually have something to contribute. As we've already seen, a lot of the visible thinking routines inherently encourage reflection, mostly about students' own thinking processes. The value of visible thinking routines in furthering the goals of the Alice Springs Declaration is really evident in a reflective concept map that students in Traverse City, Michigan were asked to complete about what makes good thinking both before and after they were exposed to visible thinking routines. So here's the concept map beforehand. You can see what this student has identified as good thinking involves very traditional views of intelligence, such as getting the right answer, getting into a good school, doing a good job on time, and having good spelling. Then, after 7 to 8 months of learning in a classroom that incorporated visible thinking routines, students' attitudes towards good thinking changed drastically. Now they value making observations so that they can explain things better, explaining ideas to themselves so they can understand them better, exploring different answers, making predictions, comparing two different ideas to see which ones make sense, and asking questions to deepen their understanding. These ideas about thinking align strongly with the type of attitudes we are trying to cultivate with the Alice Springs Declaration and with the general capabilities. There's more of a focus on the processes involved rather than pure content knowledge, and it gives children who aren't necessarily so strong in standardized testing a way to deepen their learning experiences and understand that SMART isn't just about getting straight A's. To sum up, visible thinking routines are Project Zero's way of creating a culture of thinking in the classroom in a way that thought processes are observable to maximise their usefulness to both students and teachers. They don't explicitly teach content, but help students to engage with classroom content on a deeper level and become able to do that without being told when to do so. It's wonderful if a whole school approach to visible thinking is taken, but it's just as easily implemented in a single classroom. Just before I finish up, there are a few videos that are highly beneficial, especially if you don't feel like you've 100% got it yet. First of all, there's a really great 5-minute summary on the Project Zero website, which is where I got the stills of the Venn diagram and the various thinking types. I'd highly recommend this one if you really want to shore up the basics. Finally, there's an hour-and-a-half long forum on the 50th anniversary of Project Zero, in which a lot of the presenters talk about visible thinking. For a couple more concrete examples of visible thinking routines, I've set the link in the description to start from where Shari Tishman gives some great non-maths related examples of some of the routines. So if you'd like to see some of those in action, please check out a few of those. It's also where I got the concept maps from Michigan. Unfortunately, we can't embed any of the videos in our own presentation as it would breach copyright, but I'd really encourage you to check them out. I found them really valuable. Now that you know what visible thinking is, we're going to look at some of the ways this can be structured to be incorporated into the maths classroom.